Good afternoon, everyone. Thanks for joining. We'll get going here in just about a minute. All right, good afternoon, everyone. Thanks for joining today's webinar, Keeping Traffic Moving Safely with Alpha Battery Backup. My name is Connor, and I will be your moderator. Before we get going, just a few housekeeping items I wanted to run through quickly. All phone lines are muted, so if you have any questions, please use the chat feature within your GoToWebinar toolbar. The presentation is about 45 minutes or so that'll give us some time for questions at the end. By attending today's webinar, you are eligible to earn TARP points through IMSA. For those of you who provided your IMSA number registration during the registration process, Western Systems will automatically handle the submission for you. A copy of today's slides are available for download within the GoToWebinar toolbar. And lastly, today's webinar will be made available for you to view anytime on demand at a later date. You'll receive an email tomorrow with a link that allows you to download it. All right, with the housekeeping out of the way, I'm very excited to introduce today's presenter, Kai Antrim, Territory Manager for Western Systems. Kai, the floor is yours.
All right, thank you everybody for joining us, and welcome everybody who hasn't partaken in our webinar series. We certainly appreciate you guys dialing in from wherever you are, at home, at work. Hope you're staying safe. Definitely keep an eye out in the next couple days. We plan on doing this well into the foreseeable future, especially if we continue to not be able to have in-person meetings like we're used to. On another note, a lot of these webinars are going to be kind of higher level overviews. I see a lot of attendees on here who I know are probably pretty familiar with Alpha. I see Linwood, Bill, Mike, Melissa from Sammamish, a bunch of people who are already know the system pretty well. What I'd encourage you guys, if you want to take a deeper dive into this, all of our technicians are available, and they're working at home, which it's hard enough to do sales remotely, but imagine trying to do technical support. So definitely encourage you to reach out to us and see what we can set up in terms of online technical training. If there's anything you guys hear in these webinar series that you'd like us to go kind of a little bit deeper on or expand on, we definitely encourage it. So without further ado, I'll get going here on the Alpha Battery Backup presentation. So why battery backup? ITS is becoming the core of multimodal traffic and mobility management systems, delivers the benefit of providing real-time information, helps you make smarter, more efficient use of transportation networks. Essentially, when is backup power the most important? When is communication the most important? It's when the power goes out. That's when you want your communications to be working well. That's when they're needed the most. You guys still able to hear me here? So we're talking about the liability that comes with having your power go out. So with battery backup systems, as we move to LED lights and lower powered, lower consuming devices in our traffic signal cabinet, it's become feasible to back up our entire traffic signal network for a number of hours using batteries and inverters. There are a number of different types of battery backup systems and UPSs out on the market. We'll just talk today about a couple of the more popular ones, but some of the names you'll see out there: double conversion, standby, and line interactive. My bullet points are a little off there, but the line interactive is what the Alpha is. It's a buck and boost system. About 90% of the systems being purchased by the agency today fall into that category, buck and boost. This first diagram is of a double conversion system. These are kind of some of the higher end systems that you'll see out there. And the whole idea with the double conversion system is the utility power, no matter what the state is of the utility power, it's going to be running through the inverter. So that creates some issues. It means the heat's always on. It means your batteries are being worked 24/7, even if it's not necessarily required. But it does mean that you get clean, exactly 120 volt power at all times, because as the utility power comes in, goes to your transfer switch, it's then going to a surge protection device, and then through a converter. The converter is then converting it to DC, which powers your batteries, and then it goes through an inverter, so it's back to AC. AC is the voltage that's your signal heads and your things out in the field. So it's actually going through that entire process the whole time, just to clean up the power. So expensive systems, potentially not necessary for out in the signal cabinet world. Again, on a double conversion system, when the power does go out, then you're drawing off solely the batteries, going from DC to AC in the inverter and back out to the field. A line interactive system works a little bit differently. This is what the Alpha system is. It utilizes the utility power through the transfer switch. That's AC power going into the surge protection device, and then directly back out into the field if the utility power is on. At the same time, it's also sending power through the charger, which is converting it from AC to DC and into the batteries. It's a little bit more efficient. You're getting line conditioning by going through the surge protection device, and it's bucking and boosting as necessary. So when the power does come in, if your voltage is a little bit off, bucks it, it boosts it, and it's charging the batteries, but it's never using the batteries, and it's never going into inverter mode unless the power has gone out. Now, when the power does go out, then the batteries kick on and operate similar to the double online conversion system. But it's a lot more efficient. You're not putting your inverter through a rigorous workload if it's not necessary. It's only changing when the power's on, but you still get that line conditioning from the surge protection device. So if you wanted to compare the buck and boost model versus the double online conversion, your line power is coming in normally 112 to 132 volts AC. That's what our electronic components are meant to be able to withstand. If it comes in 132 to 175 volts AC, we're going to buck that power back down into the acceptable line range of 112 to 132. If it's between 85 volts AC and 112 volts, the surge protection device is actually going to boost it back up. So you've got monitoring between 85 volts AC and 175 volts AC. So it's really, we feel, and a lot of the people out there, it's worth it for about half the cost of an online conversion system, just have a system that's line interactive and doing bus boost. Again, inverter, that's one of the more expensive pieces of equipment in the traffic signal cabinet. It's always off unless it's needed. So your batteries at the same time, these are batteries that like to stay fully charged, and they are not drawing power while they're regulating a buck boost. It's not even going into the battery bank. This is a wiring diagram of the system. So it's a 48 volt DC system, which has four 12 volt batteries in parallel. So you can see in the upper left hand corner, those plug into the side of the inverter. In the middle is your LCD screen for some troubleshooting. That's where you could wire in. Below that's where you can wire in your beacons. And then most of these, and we'll show these on a couple of slides, are going to come with a UGTS, which stands for Universal Generator Transfer Switch. and a UATS, the Universal Automatic Transfer Switch. Talk a little bit about UPS battery backup systems and the different form factors they come in. They're all doing about the same thing, but Alpha gives us a wide variety of different form factors, sizes of batteries, enclosures, depending on the application. Everything from backing up ITS devices all the way to full 2,000 watt peak load intersections. So the FXM 1100 and the FXM 2000 have the same form factor. The number 1100 or 2000 corresponds to the number of watts that it's rated for. So the nomenclature is pretty simple. The standard form factor is it fits into a 19-inch rack. They also have shelf mountable versions if you're going to be sticking it inside on shelves. You can see the components, the DC breaker on the left side. There's an Ethernet port. That's where you connect your communications so that you could remotely access your inverter. The LCD screen, everything that you could do remotely, you can do on the screen. You just have to go through a handful of menus and fat finger your way to whatever you're trying to program. The input breaker is to the right of that. That's the breaker for the power, AC power, the model and the serial number on the sticker there. You can see where your line power comes in and then where it goes out into the cabinet. Your dry contact relays, this is where you program things like load shedding. Those are all can be set to normally open or normally closed or constant voltage. So that's where you would plug in maybe a tattle light. So some people like to have a little LED on top of their cabinet that illuminates when you're in battery backup, so that when you drive it down the street, trying to ascertain the state of your signals, you can look very easily and see, okay, that one's in battery backup, that one requires attention. The panel is rotatable, so this is the same form factor that goes in those vertically oriented battery backup cabinets, so you don't have to look at it sideways. You can just rotate that entire LCD screen. These are your user programmable dry contacts. So you have on battery, low battery, timers, alarms. So this is where you program an alarm input to maybe send you a message or something that your battery's low or that your intersection's in flash. You could trigger any devices that you wire up here. The transfer switches, we include these with every single cabinet. As I mentioned, the generator transfer switch. Without this, you would be manually wiring in the a generator. If you, the typical operating procedure is to run on batteries, and then if the power outage is still going, you can go out and plug in a generator. So having the UGTS gives you the ability to just have that either automatically switch or when it feels that you've plugged in a generator. So that's a good feature. Same thing with the transfer switch. The transfer switch is going to flip on when utility power is lost. So you don't have to rewire anything. It just happens automatically. So each of those is included with each of the cabinet builds. This is a screenshot of an FXM inverter. This is the kind of thing that if you guys want to be run through a little higher or a little deeper dive into this while we're all quiet and stuck at home, we'd be happy to log into our demo site and run you guys through each of the menus. But real quickly, your UPS specification, when you call in and you're asking for help, we might ask you, okay, are you using an FXM 650, an 1100, what model is it? All that information is going to be under the UPS specification there. UPS monitoring, you can't actually do anything in there besides view your inputs and outputs, your battery and inverter, relays and load shedding, and things like that. So that's a screen. Those menus are for just taking a glance at your system health. UPS maintenance, that's where you actually go in during your preventative maintenance and see how things are doing. So you check on the battery. That's where you're going to program your battery tests. So when you buy a unit from us, we're happy to come out for a turn on. There's a couple settings that we recommend changing kind of right out of the box. Alpha is a Canadian company, so everything comes in Celsius. So go in and change that so you don't have weird alarms going off. Another thing that we recommend is, depending on how bad your power outages are, this is where you want to program load shedding. So believe that the setting, it automatically load sheds down to 20%, what is it, every couple of weeks or something. So that's definitely a setting that it's a good idea to go in there. And if you do get out to your cabinets, or you don't have a huge city network that takes you forever to get to, if you can get out there multiple times a year, it might be better to just do the battery test on your own. If not, you can set it up automatically. If it's getting somewhat regular use, we recommend maybe only draining your batteries down 5 or 7% during the battery test. Otherwise, you're putting your battery through unnecessary strain. Batteries like to be used a little bit, but they like to go up and then not too far down and all the way back up. So if you're going into inverter all the time, then your battery probably doesn't need to be tested nearly as often. If they're almost never used, then you definitely want to go out there, either set it up automatically so that the battery is able to do a little bit of a cycle. Time and date, set that to Pacific Standard Time. This is where you would configure your password, and then your event managers when you trigger your alarms and faults. Where you set up your email and things like that to make sure you're getting notifications when certain user programmable events happen with the system. Batteries. We'll talk to you a little bit about the batteries. As I mentioned, 12-volt batteries. We use a lead acid battery. That's the XTV batteries that we've been providing you. Couple different battery types out there. There's gel, AGM, hybrid, and nickel zinc. So we've kind of settled on the hybrid, the XTV battery. It's kind of the best of both worlds. If you guys have been buying Alpha systems from us for a long time, we used to sell the gel batteries, and it turns out that the gel batteries were really, really good in somewhat warm climates because the gel is in there and it likes to be able to move around. The gel's not so good in the cold climates, so that's why you saw us provide battery heater mats. The hybrid batteries seem to perform very well in all parts of the country, especially here in the Pacific Northwest. So if you start seeing us providing those without battery heater mats, don't be alarmed. And if we accidentally do include battery heater mats in your quote, you can. It's kind of up to you if you want to use them or not, but it doesn't require the same considerations as the gel batteries did. Design life, batteries are they come in all different flavors. The length we expect them to last varies by manufacturer and model. You can kind of break them down into general purpose batteries. It's your car batteries, your lawnmower batteries. Those are going to be 5 years. High quality batteries, engineered for purpose-built type applications like this, so they're going to be 10+ years. Of course, being in different environments can reduce the actual life. We're over in Kennewick, where it stays nice and dry and warm, and they have had the same batteries out there for 12 years, not leaking or anything, and they get used all the time. They've got really dirty power over there, so it's really worth it. Having a longer design life makes the system a lot more reliable. So the design life, so to speak, is always longer than the expected life. But you can see the hybrid batteries; they're right up there with nickel zinc as being able to last the longest. We'll go into run times a little bit more, which is kind of the next consideration. And hybrids seem to be a lot more efficient in running the types of loads for longer periods of time out at the intersection. MK batteries versus AlphaCell batteries, 10-year design life. This is kind of what we see in Tesco cabinets. They're these little batteries that seem to have a lot more problems with run times. They don't last nearly as long. Alpha offers a 5-year warranty. been around since, those XTV batteries have been around since 2014 and give you a lot more options and sizing. We go from 100 XTV batteries, which are 56 amp hours, and we have 4 choices between there, and 240 XTVs, which are 112 amp hour batteries. We say it's got an 8-year expected life. As I mentioned, we have seen these batteries last far longer than that. One of the key differentiators, we go out there and we talk about battery backup systems, and a number of our agencies say, yes, we like the idea of having backup power, but just like anything, how much more maintenance is going to be required when we add batteries to just yet another thing that we have to inventory, keep track of. Batteries have kind of a bad rep for always causing more service calls. So the remote battery monitoring system helps mitigate a lot of those concerns. It's designed to do 95% of your preventative maintenance for you. Can monitor up to 8 batteries, comes with 4 sensors, works with a 48 volt or a 24 volt system. So instead of going out there with a multimeter and checking your batteries, you're able to get each individual battery's temperature, voltage, temperatures, and admittance. It's also IP addressable. So in addition to doing its normal battery balancing, it's got built-in web pages and management software so that you can program to receive alerts when, again, user definable events happen. So bad battery, instead of going out and needing to do preventative maintenance on this and checking each one of them, we've got this thing daisy chained onto each of the batteries, and then a temperature probe out there too. So you get a lot of information out there without having to go out in the field. Here's the wiring diagram. You'd stick, if you've just got one string, which is probably going to be the most common application, you've got your spot there for that. It actually gets its power off of the battery string. Now, one thing as a best practice that we'd recommend is it needs 21 to 59 volts DC. So a lot of people go out there and they connect the battery harness to just one battery. It's not going to be quite enough power to power that guy. So we recommend just running it across the entire string. It can take up to 59 volts DC. So going from the positive of battery 1 to the negative of battery 4 should give it plenty of power. It's also got an AC plug if you'd prefer to power it in that way. It is getting to be a decent number of wires in there by the time you've got all this daisy chained on. But essentially each of those little battery sensors that you see, it's going to have a sticky side and a Velcro side that Velcros it onto the top of the battery. And then each of those leads goes on the respective locations, negative and positive, on each of them so that it can bring each of the individual battery states back remotely. So again, why? Cost savings. So, the unit itself is not terribly expensive. It just sits in there and hums away, but it reduces having to go back out there. Reduces battery backup system maintenance. So you don't have to go out on the site nearly as often. It's giving you just about everything you go out there and do manually. It's a little bit of upfront work to get everything hooked up, but it's worth it to reduce the out time. You guys hear me still? I don't know if my headphones might have died. Just gonna keep rolling. RBMS viewer, it's got a simple graphic user interface. So you go in there and you configure the site name. So maybe first and main, wherever you're at, location, maybe neighborhood and city. It's going to tell you which string, the voltage across the entire string. So if you look at string 1 sensor data, you've got it's reading 53.8 volts DC. And then you can go into the voltages of each individual battery and the admittance. And same thing with the temperature. Each one's got a temperature probe on them, just taped to the side with some electrical tape. Enclosures. We'll talk about each one of these individually. Like I said, flexible number of mounting options. You can pole mount, you can side mount it onto the side of a cabinet, or you can mount it just on its own pedestal base. The nomenclature for Alpha cabinets is pretty simple. SE is standard enclosure, and then the first number, 48, that's going to be its height. Second number, its length, and the third, its width. So the SE 48 1616 is 48 inches tall, 16 inches wide, and 16 inches deep. When you purchase it all together, it comes with a 5-year warranty. Again, you can see the LCD screen is flipped here. This is the most common battery enclosure. The 240 XTVs, that's the large 112 amp hour, 79 pound batteries. They do fit in here. So this is a popular option for that. It's also compact and light enough that you can just bolt it to the side of an existing cabinet for retrofits. Some of the options you guys have is optional generator switch. So it's an actual generator plug on the outside of the cabinet. It's a make before break. So when you plug it in, it's going through the inverter, making sure you're getting clean power that's getting the buck and boost function from the surge protection device. Comes standard with fans and filter. Either lock that you guys might use, best lock or number 2 are both available. You can also have a police door on it, and we're happy to powder coat it any color that you might need. The SE 482216, this came about as a result of people saying that they wanted something just a little bit larger. When you're pedestal mounting the 1616, it's pretty small. People actually thought we've got room to go a little bit bigger and have a little bit more space in here. So in terms of the first shelf with the inverter and the transfer switches, all of that remains the same. However, you've got enough room in the battery compartment there to put slide out shelves or fold down shelves or something to help you get the batteries in and out easier. It's just a little bit more room, flexibility by going six inches wide. So again, all the other options are pretty much the same, but just a little bit more room. The SE 48 1909, again, 48 inches tall, 19 inches wide, and 9 inches deep. This is made to just hold the batteries. So we see this on the side of a number of 332 style cabinets because the 332 style's got racks in it already. So some people like to put their inverters and transfer switches inside the cabinet, and then the batteries in a separate compartment outside. This is a good option for that. Again, it can accommodate all sizes of batteries. And the purpose of this would be to minimize temperature differential between the batteries. So sticking them all on the side there is sometimes better than sticking in the cabinet. So when you're designing a system, and this goes for also writing specs and determining what you want out of a battery backup system, most important thing is determine the load. We want to have an idea once you add up all of your devices out there that you're looking to back up, what kind of load is required, and really right size the inverter to that size system. The inverter likes to be used every now and then, and likes to be used to its full capability. Otherwise, it has the potential to reduce the life of it. So if you're only going to be running a 600 watt load or 800 watt load, you don't need the FXM 2000. Slightly more expensive, and you're reducing its potential operating life by leaving so much of its capacity underutilized. Runtime required. Typically with these intersections, we're recommending the largest battery possible, which is the 112 amp hour 79 pounder. But if you are looking to reduce the size of the batteries, or certainly application specific, if you're not backing up entire traffic signal cabinet, let's find out how long you need to run your devices, and that'll give us an idea of the load on the battery and then the size necessary. Again, for the cabinet, what exactly are you willing to do? Are you going to retrofit an existing cabinet? Are you going to pour a new foundation and pedestal mount it? So these are all design considerations to think about when you're asking your Western Systems rep for a quote on a battery backup system. some of the specification items when you're putting these into your projects. UPS type, if you call out line interactive, that's going to reduce a lot of your off-the-shelf battery backup systems that aren't doing any sort of line condition. Intersection runtime, this is a good one. Say our intersection is X number of watts, we need it to run 4 hours, and then Western System will do a calculation for you and show you that it would have the ability to run for X amount of time. That's a good one because that's what people are often most concerned about when they put in a battery backup. How long is this going to run in an outage? Output capacity, this helps you size your inverter. System voltage, a lot of systems are 24 volts. You've got every flavor out there on the market. So when you're putting specification in, putting in that you require a 48 volt DC system. User interface and communications. The RBMS is a very, I guess, specable device that not a lot of other battery backup manufacturers can claim to have. The event logs, you've got over 200 lines. So quick story about, we have a battery backup system over in Pasco, Washington. They had never even looked at it in like the 8 years it was out there. And they said, we don't know. We don't get any complaints, but we wouldn't anyways because the rest of the intersections are dark when the power goes out. And we went out there, and in the previous 4 days, it filled in that entire event log of 200 lines. So we kind of looked at it and said, well, it's doing its job. They were really putting it to work, and it had really, really shoddy power out there in the Tri-Cities area. So having that event log and being able to take that to your engineer or whoever's got the funding and saying, this is the kind of power we have out there. If you guys don't have a battery backup system yet, Western Systems would be happy to, do a trial before buying a system to show you guys just what kind of power you have and what kind of events come up. A lot of people would be surprised at just how dirty the power is coming in. Spec the cabinet and battery size, warranty. I think it's only 5-year warranty on the market. Local support. Everybody at Western Systems is competent and familiar with the programming and configuration of the units. Also, Alpha is UL listed and marked. It's not just tested to those standards. We'll run through some preventative maintenance. Again, a lot of these things are taken care of by the RBMS, but you can go, if you are out in the field, you can check the LCD display. It'll batch any of the messages there, so alarms, faults. You can scroll through. You can even look at the event log right there out in the field. Check the wiring, check the battery wiring, check for loose connections, corrosions, that kind of thing. We do recommend putting a little bit of electronic goop on the posts when you first install it, but just make sure everything looks clean. Another thing that people are interested in, check the UPS runtime counters. Sometimes if you're just putting these out there and you're not familiar with how the utility power is, you don't really have a baseline. So maybe you set it up and you just leave everything on primarily its default settings. You let it run for a couple months, you go out there and look at it and say, okay, based on how much time we've gone into UPS, I'm going to change the load shedding that happens. I'm going to make sure that it's doing a self-test from time to time. I don't know if I have a slide in here, so I want to talk to you guys a little bit about load shedding. That just reminded me of that. The typical configuration of the units is to just run the entire load of the intersection, barring any other programming, until either the power comes on or the batteries die. One of the cool features of the Alpha system is that you can program it, and this is what you do in those dry contacts on the front screen. You can program load shedding. So maybe for the first hour you want to be in full color with everything working great. You've decided that 80% of your power outages only last an hour anyways. So you want to say, okay, for 1 hour we're going to run full operation, everything. And then if it does happen to get to a second hour, okay, I still want that full color functionality. Let's kill our detection. We still want communications to the controller. We still want, to be able to coordinate to the intersection down the corridor. But we don't need laser detection to kill that. But you kill your PTZ camera or something like that and say, okay, keep running in color. You can go down that list of devices that are priority before you decide to go into all flash. Some people say, okay, I want to go for 2 hours full color and then just flash, until the batteries die. And in flash, the intersection can run, I think up to 24 hours. So another thing that's programmable is the time of day clock that's in there. So you can set the load shedding to be based on the time of day. So maybe if the power goes out, it's 5 p.m., you want to make sure it's full color to get everybody through that rush hour traffic. But if you get a power outage at 2 a.m. or something, you're going to say, okay, well, there's hardly any traffic there anyways. Let's just go into flash right away. So that's one of the cool things you can do in the inverter is decide when and where what devices you actually want to back up. Back to the preventative maintenance. Verify the cabinet fan works. That's important for just maintaining the temperature in there. Batteries like to be at a certain temperature. The inverter, you don't want to get the inverter too hot. So verify that and then check the filter, make sure it's clean. I guess that's it. All right. Anybody have any questions?
All right, Kai, yeah, thanks. We'll go ahead and get going on the question and answer portion of today's presentation. Please use the chat feature within the GoToWebinar toolbar if you have any questions you want to ask. But before we get going, just wanted to remind everyone to keep an eye out on their email inbox. We'll be having some future webinars and we'll be communicating them all out to you. So just make sure you have an eye out for that. All right, let's go ahead and get going with the question and answer. We got our first one here, which is, how do Alpha batteries compare in cost to Teso and Zinc 5?
Yeah, so what we found is the comparison is they're generally less expensive than the competitor batteries, but a better way to answer that is what runtime requirements do you have? Because if you wanted to run an intersection for 2 hours off an Alpha system and 2 hours off a Zinc 5 system, it's going to take a lot more Zinc 5 batteries than it is per dollar of Alpha battery. So generally the value overall is better, and if you were to compare the systems side by side, all in all, the Alpha is definitely competitively priced.
Great. Next question for you, Kai, is Alpha on the Washington State contract?
It is. Yep. So Alpha is the standard. Not only is it on the Washington State DES contract, it's also the wash.spec for cabinets. So they put theirs in a 332 style cabinet because it's rack mountable, but they have them all over the state, not only for traffic applications, but also for things like remote ITS stuff. Their radio shop uses Alpha, so it's very prevalent in Washington State.
Next one for you. Should I use battery heater mats in Western Washington?
So if you have the XTV batteries, they're optimized for the temperature around here. Gel batteries are going to be a lot more susceptible to cold temperatures, but with a lead acid battery, which is what we're providing now for the Alpha units, it's not necessary to have a heater mat.
All right. Can the Alpha UPS be used in a Western Systems NEMA cabinet?
Yeah, I'm glad you asked, and I definitely am remiss to not have a slide on that, but Western Systems makes a P+ cabinet. If you've heard any of our presentations or gone to any of the shows, you've probably seen one, but what we've done is we've integrated a battery backup system directly in a NEMA cabinet. It's not a retrofit option because it's requires a completely new shell, but it does fit in a standard P44 footprint. So if you are replacing a cabinet and already have a pedestal, there's no space concerns there. It'll bolt right on. What we've done is separated out the batteries on the right side and created a second door that opens to the outside so the batteries can stay in their home. This is it in the lower right-hand corner if you guys are still looking at our screen. And then the inverter and transfer switch, they are placed vertically, just like they would be in an alpha unit. And we've put slots in there that kind of emulate a 19-inch vertical rack inside the alpha units for the inverter inside the cabinet. So we definitely recommend you checking that out. That's the standard for a number of the agencies around here. I think Sammamish was on the call. They're using the Stretch P Plus cabinet. Any Western Systems cabinet that you see with the plus nomenclature, that indicates that it has battery backup. Seattle's using it, Kirkland, Auburn, a number of agencies in the area.
Great. Next one for you. How do agencies decide which intersections to put the Alpha battery backup system?
Yeah, sure. So that's in a lot of ways that's an engineering decision, that they make based on data. But what we see a lot is busier intersections that have a history of right angle or head-on or rear-end collisions because of the lights being off. We definitely say, stick it on your worst intersection. So if you're strategically going through your city and deciding which ones deserve it because you're not doing a wholesale change out or you don't have very many, then yes, I'd look at your volumes and I'd look at where it makes the most difference if the power goes out, because there's a lot of emphasis on the safety aspect, as there should be, to keeping the lights in full color for as long as possible. But if you lose a signal that's way out, in a rural area, and you lose comms to that signal, it's not nearly as obtrusive to your network as losing comms at like maybe a backhaul location. So definitely looking at your network, and that's something that John Brandon, our tech guy, and any of your sales guys should be able to walk you through and help you prioritize if you want some advice on that.
Does Alpha have other inverters to back up network communications?
So other inverters, the ones that are within my purview, so Alpha itself is a subsidiary of EnerSys, which is a huge global company. But within our purview are 350 watt, which should be very, very small. We call it the micro system. It'd be for backing up some cameras or something. They have an FXM 650, which is 650 watts. That's getting a little bit larger. Could run an intersection for a little bit. You wouldn't get the same run times. And then obviously the 1100 and the 2000. So lots of options, if that answers your question, across the inverter size spectrum. Yeah.
Great. Looks like this may be the last question here. Is it possible to include a generator plug within the unit?
Sure. So the generator plug itself is an option that can be on the external part of the unit, and so it'd just be a little locking door on the side. You plug it in, and it would have a little cutout on it for the cord to come out. So you could set it and then leave it there until you charge your battery sufficiently, and then move it on to the next location. So certainly.
All right, thanks, Kyle. Looks like that's the last question. We appreciate everyone attending today's webinar, and have a great rest of your afternoon.
All right. Thanks, Connor.